topic that we are going to discuss is what is rates. The rate is very closely connected with what we call as ratio. In fact, I think the word ratio has been derived out of the word rate. Was initially must have been some kind of rate and then it became a ratio. We call it rate because certain things we buy and we say the rate of this. Supposedly you buy 20 pencils for 300 rupees. And then you say one pencil is for 15 rupees. And then you say the rate of pencil is this. So rate is the amount of money you pay for one. The rate of petrol is the amount of money you pay for 1 liter of petrol. The amount of money you pay to get one smartphone. That's the rate of a smartphone. But that's not what we are talking about here. Here, the discussion is not about rate in terms of money. Here, the rate is about something else. And what is that something else? Let's see. So, the context is, supposedly a car is running from point A to point B. The distance between this is 300 kilometers. And for covering the 300 kilometer distance, the car has taken 5 hours. So what we say is the car covered 300 kilometers in 5 hours. We also understand that if the number of hours are reduced, then the distance will also be reduced proportionally. If the number of hours are increased, then it will accordingly increase the distance. So what we do is we say what will be the distance covered in 1 hour. So if we divide this by 5, we get 60 kilometers in 1 hour. This is like saying we take distance upon time. Whenever the ratio has time in the denominator, we call it rate. So in this case, we have distance upon time and we call this as speed. This is the rate of traveling, the rate at which the distances are covered or traveled. The rate is how much has changed, maybe the distance from a particular place, maybe the displacement, or maybe something else, whatever that change you're talking about in 1 unit time. The change upon time is called as rate. It is based on the logic that in our life things change with time. We say that with time, if there is a problem in someone's life, people give advice saying give it time. What does it mean? Do you have time in your pocket that you can give? It's not like that. Give it time is after some time things change, and when the things change, what is very difficult for you will become less difficult. There is a saying which says if you are in really big trouble, don't worry because the things will change with time. And if you are in an extremely good situation, extremely happy situation, worry because the things will change with time. All these sayings are the change will happen with time. And if we are to measure how much change has taken place per unit time, then we say this is the rate of change taking place. The rate of movement of a car is kilometer per hour. How many kilometers per hour? Rate of movement of a person can be measured as how many meters in 1 second. The rate of movement of seasons can be measured as how many seasons per year. We can go up to any level with this kind of discussion. In this chapter, we are only dealing with distance and time for rates. But there is one more rate which will come in the next section, which is called as kinematic graph. We will discuss that in graph. But we must know that the rate is basically a ratio in the denominator is always associated with time. If that is clear, we can just see the numerator. The rest is very easy. Let's see the first numerator. The one example 11. 492 people live in an area of 12 kilometers square. express this as a rate in its simplest form. Again, in this case, this is not with respect to time now, but this is the rate of people's inhabitation per unit area. Now, in this case, we'll say that 492 people upon 12 kilometers square is equal to 492 upon 12. We'll divide this. 12 fours are 480 and then 12 ones. So 41 people in 1 square kilometer. This is the rate of inhabitation. But again, this would have been better called as a ratio of the number of people per the space available, per the area available. But fair, this is also rate, like we talk about the rate of objects, the amount of money per unit object, per one object. Similarly, the amount of people or the number of people, not amount, the number of people per unit area. This is also called as population density. Number of people per square kilometer is called as population density. Might be an important term for geography. Here it is population density. Next, let's see the next problem. Average speed. Now we'll talk about what we have been talking about. Supposedly you initially travel very fast and you cover 100 kilometers and you literally take only 80 minutes. So that is slightly more than 1 hour. But then there is traffic on the road. And next we only cover 80 kilometers in 100 minutes. So it is clear that the speed has been variable. Here the speed was pretty fast, pretty good, pretty large because you covered more distance and in that for them lesser amount of time. In this case, the speed was reduced because you were covering less distance for a greater time. But in all of this put together, what we call as average velocity or average speed. Average speed means the speed of the entire journey taken together. And that is the total distance upon total time. And this is 100 plus 80 is 180 kilometers divided by 80 minutes plus 100 minutes is 180 minutes, 3 hours. We could have kept it in minutes as well, but normally the even for speed is taken as either meter per second or kilometer per hour. So I avoided writing minutes here. So we get 180 upon 3 is 60 kilometers per hour. This is the speed of the vehicle. This is not the instantaneous speed, or this is not the speed all the time. When the traffic was very less, the car was going at much faster speed than 60. But when there was more traffic, the roads were narrow, the speed reduced and it went much below 60. But what was above 60 in one case, what was below 60 in one case, everything put together, it comes out at the average is 60 km per hour. This is not the actual speed every moment of time, but this is the speed for the overall journey because this is the overall distance upon the overall time. And I think we all understand that no matter which vehicle we use, our speed is never 100% constant. Even if our speedometer shows a steady mark, it is not always constant. What happens is, it is the power delivered by the engine and the speedometer is already made a deadbeat galvanometer. That is the galvanometer. It is basically galvanometer converted into speedometer, and the beat of that, the indicator of that, was initially going to very fluctuating. There has been a specific arrangement with current that has been made there, so that the flow of this or the indication of this is very steady. It does not mean that a car's speed is steady. You can understand when your car is going, there will be winds blowing in this direction, and with every wind, every stream of wind coming, the opposition to the car's motion is going to be changing, and because of that the speed can increase or decrease. This is very typical, and we understand when we are driving in the car, or even if you are not driving, if you are sitting in the car, you feel that the speed has slightly changed because of the other conditions. the speed will never be constant. What we are calculating here is not a constant speed, but this is the average. Now let's see a numerical based on this. What we are going to do is, let's take a case where the total distance traveled is 200 km and the time taken is 5 hours. For 5 hours, maybe the road was such, maybe the vehicle that we chose was such. If we go on a bike, we can actually maneuver our body. If you are traveling in a bus, it is very difficult to maneuver the way. So the bus will be having a much lesser speed. So in whichever condition, the average speed is equal to distance upon time. 200 5 is equal to 40. In physics, we have discussed as to why we call speed is equal to distance upon time. The formula speed is equal to distance upon time has been derived out of physics. And why is this formula? Why do we accept this formula? Where does this come from? It is a very simple logic. Just assume that time is constant. So we are traveling for the same amount of time. And here is somebody else. I am faster, so I reach here in 1 second or 2 seconds. And the someone else who is actually with me, or my friend, only reaches this point. I reach this point in the same amount of time. So we know that one person has reached from here to here, the second person has only reached here. Then we say this person is slow because he traveled less distance. So it is the speed is less, the man is slow if the distance is less. So these two are directly dependent. Now let's take the case of a race. Whenever you are running a race, the distance is constant. Speed is the time is not constant. The distance is given. The starting line and finishing line is defined. You will start from the starting line. Whoever reaches the finishing line first is declared the winner. So if you reach the finishing line first, whoever reaches the finishing line before, he takes less time. The time is less. And if the time is less, the speed is more. That's why he reached early. He reached fast. So the distance is constant. Speed and time are inversely proportional, or they are contradictory, or they are oppositely related to each other. The time is more than the speed is less. If the speed is more than the time is less. So we understand that these two are not going to be inevitable. The speed is inversely proportional to time, speed is directly proportional to distance. We put this together, we say speed is equal to distance upon time. This is how we get the formula. We'll use the formula in this session to get the answers. Let's see the exercise now. A bus travels 210 kilometers in 3 hours. What is the average speed of the bus in kilometers per hour? 210 kilometer distance, 3 hours is the time. 210 upon 3, 70 kilometers per hour. This is just far too easy. Anything else? Yeah, okay. Walk at 4.5 kilometers per hour. The speed is given. How far can I walk in 2.5 hours? At the same speed, assuming that the speed is constant. So speed is equal to distance upon time, so distance is equal to speed into time. Speed is 4.5, time is 2.5, 2.5. 4.5 into 2.5 is 11.25. You get the answer. That's it. The next one. Let's see the exercise. Express each of the relationships as a rate in simplest form. 12 kg for $5. So this can be expressed as rate. So $5 for 12 kg. This is equal to, and then we can just divide it. I think it will be 0.4 and 166. 6 will be recurring. So we get this 5 at 0.416. You can verify with the so this is the dollars, so many dollars per kg. So if you want to buy 1 kilogram, you have to pay $89. Or you can convert this to cents and say 41.66 cents. $315 for the 120 liters for 1000 kilometers. So 1000 kilometer upon 120 liter. The amount of distance, number of kilometers that you travel per liter, per unit liter of fuel is called as mileage. AGP is a suffix that we attach in the end when we talk about the measure of the. If you know, then how much you know is measured with your knowledge. So after we add an AGP. Now how many miles will you travel? At AGP it becomes mileage. English has a set of rules about how adjectives are formed from nouns and nouns are formed from adjectives. So the mileage here is 1000 kilometers per 120 liter. Let's get it out to 0 and divide by 12. So 100 upon 12 is 896. 4 by 3 is 333. 8.3. So 8.3 kilometers per hour per liter. Must have been a bus or something because the cars or the vehicles will give you slightly better mileage. But nonetheless, we get this value. $315 for 3 nights. You book a hotel and they will charge you per night stay. So how much money? 315. How many nights you spend in night there? Divide. You get 105. $105 per night is the rate for the stay in that hotel. Similarly, 5 kilometers in 20 minutes. You keep 5 kilometers upon 20 minutes is 1 by 3 hour. 20 by 60 is 1 by 3 hour. Then you divide by a number, it means you multiply by 0. So we have 5 into 3 by 1, which is equal to 15 kilometers. And you get this one. Question number 2. A quarry produces 12,000 t of crushed stone per hour. This is a machine that is producing 12,000 tons of crushed stone per hour. How much stone could it supply in 8-hour shift? So this is the rate of production of the crushed stone. So you put in the stone, there is a huge machine and you will crush that. It will take time, but you have 1 hour. In 1 hour, you get 12,000 tons. 1200 tons, sorry. So if you have 1200 tons per hour, in 8 hours, so it is 1200 per hour into 8 hours is equal to 9600 tons. Sometimes students ask, so should we multiply or should we divide? You just check. If you divide, what will you get? 1200 upon 8, you get 150. Now you have to decide. If the given machine was producing 1200 tons in 1 hour, then in 8 hours will you get only 150? No, this is absurd. Because 1200 was achieved in 1 hour. In 8 hours you will achieve much more. So multiply. Remember this, it is sometimes the numericals will be slightly confusing, but it is our job to ensure that we do not lose marks. If we were to lose marks, then better are the students who don't study and lose marks, because at least they were enjoying throughout the year. We are here sacrificing our vacations, studying here. We must make the best out of this now. Now losing marks because of a mistake is not in our favor at all. 5-hour shift. 5 8-hour shift. Okay, not 1 8-hour. This is a 5 8-hour shift in the second case. So in 8-hour shift you get 9600 tons. This is in one shift, and you have such 5 shifts. So into 5. So it is 48,000 tons of stone crushed in 5 8-hour shifts. Water leaks from a pipe at the rate of 5 liters per hour. The leakage is small, but whatever the leakage, it is continuous. And as a result of that, if it is 1 hour, then a lot of water has leaked out. That is measured to be 5 liters per hour. How much water will leak from the pipe in a day and in very simple 5 liters per hour. In a day there are 24 hours. Multiply, you get 120 liters. It's a common sense. In 1 hour you have 5 liters. In 24 hours you must have much more. So you multiply. And you get the answer 120 liters per 1 day. 1 week, 7 days, multiply into 7. 120 into 7 is 840. You get the answer. A machine fills containers. A machine fills containers at a rate of 135 containers per minute. Now this must be something very special. 135 containers is huge. Or maybe it is my mistake. I was thinking about the containers on a ship. This is impossible. Maybe there are some very small containers like pet bottles, and the machine is just going to fill that with the cold drink, and then just it just move, and the next pet bottle cold drink is filled, next 135 such bottles or containers in 1 minute. How long will it take to fill 1,000 containers at the same time? Let's see. In such situations, it is very important that we write it properly. That it is 135 containers in 1 minute. So 1,000 containers x minute. I would rather encourage we convert things into seconds. So we have 135 in 60 seconds and 1,000 in x seconds. So 135 liters, 135 containers in 60 seconds. 1,000 containers in how much seconds? Let's say x seconds. Just divide. So get 135 upon 60 is equal to 1,000 upon x. The number of containers filled per second is equal to number of containers filled per second. The rates are equal. The ratio, these are equivalent ratios. Because the rates are equal, we just cross multiply to get 135x is equal to 60 into 1000 is 60,000. Divide it and you get the answer. X is equal to 60,000 upon 135. And this will give us the answer. Alright, I think this should be enough. There are many other problems as well, not hard, some other. I suggest that you solve this. I don't think this is any problem is very difficult here. But I would like you to solve it. You know if there is any difficulty, you can just message me on our group or personally. And I'll solve the problem and send you a solution. Thank you so much.